value inside the absolute value bars could be positive or negative. That's why we had to work the equation twice. So we said, because we don't know if it was positive or negative inside of those brackets, every time we're solving an equation right now, we're setting it up two ways, right? Okay. And then it says, also in our review unit, unit 1, we had to know and versus or statements when we were dealing with inequalities. So we called those conjunction and disconjunction. The conjunction was when it was all written as one whole statement, like negative 3 is less than x is less than 3, all one line. We also had disconjunction, which were or statements. They might say x is less than negative 3 or x is greater than 4. We had it written two separate ways. And we usually knew what the graph of those would look like. We said if we had an and statement, that it was between the 2 points. That's when our line was connected on the number line between the 2 points. So ands were usually connected. And for the ors, that's when our arrows were going opposite directions, right? And they also want us to fill in this chart to make sure we remember what these symbols mean and what they do for our number line. So this symbol right here basically says something is less than something else, right? So the meaning here is less than. Which means this symbol is our good. Okay? And these little lines underneath, all that does is add an equal to, right? So this one is less than or equal to, which means the last one is what? Good. And with those symbols, we knew that the points that we drew on our number line were either going to be open or closed dots. Okay. So if it does not have the equal to symbol, was it open or closed? Open. So that would mean the less than and the greater than would both be open. What about those last two? Closed, because they have the equal to sign. Good. And those symbols also told us which directions our arrows would point, right? If I'm saying that whatever I have is less than some number, am I going to the left or right? Good. But if I'm saying something is greater than, I'm going to the right. Okay, what about less than or equal to? Good. Which means my last one, good. Alright, good. I'm glad you guys remember all that from Unit 1. Okay, so in today's lesson, we're going to be solving absolute value equations that now have inequalities in them instead of just an equal sign. But basically all that's doing is combining these two ideas that we already know. So we've been practicing solving absolute values for a couple days. We've done inequalities before, we're just putting the two ideas together. Alright, so here is some helpful information for how to write our final answer. This says, for all real numbers a and b, if b is greater than 0, these are our statements. So if the absolute value of a is less than b, we're going to write it like this, which is an and statement. when it's all in one line. If the absolute value of A is greater than B, we're going to write it as an OR statement. Alright, so this is what it looks like when it's AND. This is what it looks like when it's OR. We have two separate ones. And this is also true if it has the equal to sign. Okay? So let's flip it over on the back and look at some actual examples. Okay, it tells us to solve these. So, just like we've been doing, we know that we have no way of knowing if the variable that's in there was positive or negative because they both come out positive. So we still have to set up the two separate equations. So the first one, I'm going to leave it just as it is. 3x plus 4 is less than 8. Okay. My second equation, we know we have to make the 8 negative. When you're dealing with an inequality, not only do you change the sign of the other side, you flip the inequality. So now it's going to be greater than negative 8. And then we're just going to solve these two equations. So, first I would need to move the 4, right? So I'm going to subtract. And what is 8 minus 4? Good. And then what should I do? Good. And 3 is not going to go into 4, so I'm leaving it as a fraction. X is less than 4 over 3. No decimals, just like on the other problems. Okay, same idea here. We're going to have to move that 4, but this time I'm subtracting 4 from negative 8. What's that going to give me? Good. Alright, and then my last step would be to and what is negative 12 divided by 3? Negative 4. I did not divide by a negative, so I do not flip the inequality. Okay? Okay, so good news. On these ones, you do not have to go back and check them in the original. We're going to stick with these two answers. We do have to put them on the number line, though. But that's a little bit easier than checking. So, keeping these two inequalities in mind, I come down here on my number line. There's 0. 4/3 is positive, so it's got to be over here somewhere. Negative 4 is negative, so it's got to be over here somewhere. And now I'm going to graph these. First of all, are my dots open or closed? Good. Okay, now this first one says that x is less than 4/3, so I'm going to the, good, so go in this direction. Alright, this one says that x is greater than negative 4. So from negative 4, I'm going to the right. So this is the type that is connected, right? Is this an and or an or if it's connected? And. That's what we wrote on that front page. An and statement is connected. An and statement is when it's written all as one thing, so that's how I have to write my inequality. We always put the smallest number first, so for us that's negative 4 is less than, my variable, is less than my big number, which was 4/3. So if you have an and you will put your small number here and your big number here, your inequalities will always point this direction every time. Alright? Okay, let's look at number 2. So again, it's already isolated. I just need to set up my two equations. So I'm going to have a plus 9 is greater than or equal to 30. And now what's my second one going to be? And I have to flip the inequality. Good. And now I just solve. Well, the only thing I have to do is move the 9, right? And what is 30 minus 9? Good. So I have A is greater than or equal to 21. On the other side, I'm subtracting from negative 30, so I have A is less than or equal to. Good. Alright, so there are my two solutions. I just need to put them on the number line. So negative 39, somewhere down here. Positive 21, somewhere down here. Are my dots open or closed? Closed. So I got a closed one here and a closed one here. So starting with this first inequality, if I want to show it's greater than 21, from 21 I'm going to the, alright, here, less than negative 39 would be to the, so do I have an and or an or here? Or. So all I need to do is go in and put or between my two inequalities. So here was my final inequality for an and. Here's my final if it's an or. Alright. So far so good?
Yeah.
Alright, so on numbers 3 and 4, it's the same process, but remember we do have to isolate the absolute value before we can set up our two equations. So on number 3, what do I need to get rid of? That's 6. So it's dividing by 6, so I would have to, on both sides. Alright, that's going to make these divide out. So I'm going to have the absolute value of 5f minus 2 is greater than, good. And that's what I'll use for my two equations. So the first one, just as it's written, 5f minus 2 is greater than 24. And what would my second one be?
5f minus 2.
Good. Alright, and my first step would be to move the negative 2. So I add it. And then I would need to, good. So I have f is greater than 26 over 5. Alright, same idea here. Gotta move the 2, so I add it. This time I'm adding it to a negative, and then I would divide again. So I have f is less than negative 22 over 5. So these are my two solutions. Now I'm just going to put these on this number line. So I got 0 here, 26 over 5 over here, and negative 22 over 5 over here. Are my dots open or closed? Good. Okay. And this first inequality, I want f to be greater than 26 over 5, so I'm going to the, and I want f to be less than negative 22 over 5, so I'm going to the, so this is and or an or. So I put the word or in between, and there we go. So before I could set up my two equations, I had to isolate. So what did you guys do? Okay. So I subtract 5 from both sides of the inequality, and I was left with 4p plus 2, or the absolute value of 4p plus 2, is less than 42. And I set up two equations based on that. So I had 4p plus 2 is less than 42, and what was my second equation? We just had to solve. So I need to move the 2 first. So I was left with 4p is less than 40. And then we had to divide. So I'm left with p is less than 10. Okay, over here, same process. Got to move the 2 by subtracting. Negative 42 minus 2 gave us negative 44. step would be to divide. So I have P is greater than,
Negative.
good. And then I just have to put these on the number line. So I come down here, here's 0, here's negative 11, and here's 10. Dots open or close? Good. Alright, so starting with this first inequality, P is less than, so I'm going to the left, and P is greater than negative 11, so from a negative 11 I'm going to the, so they run into each other. So this would be connected, which is what kind of statement?
Negative 11.
Which is an and statement. Right. Okay? So yes, we put the small number first, less than our variable, less than our big number.